So exponentials and logarithmic functions, again, this is day 2, Tuesday. Just a refresher from what we learned yesterday. We've got exponential forms and logarithmic forms. We're going to flip-flop between them in order to solve them. But we've got these two special rules that we have where b and our argument have to be positive and b can't be 1. Okay, we talked about that yesterday. If that's still unclear to you, go back, look at Monday, the 4th, January 4th video about that, or send an email, ask a question in class, etc. Okay? Today, what I want to focus in on is I want to focus in on evaluating logarithmic functions. Okay? So, for instance, log base 2 of 8. Can that be equal to something? Again, logs are exponent finders. So how I go about these is I set them equal to a box. Okay? And what number is going to fill in that box? It's going to be an exponent that I have to put on my base. So I'm thinking, what exponent do I have to put onto 2 to get 8? Now, if you see what I did there, I switched forms. That's how we're going to be solving all of these problems throughout the rest of the week and the rest of the semester. We're going to be switching forms with it. So what exponent do I have to put onto 2? Well, 2 times 2 is 4, times 2 is 8. So an exponent here of 3 would be what the log base 2 of 8 is equal to. So log base 2 of 8 really, truly is equal to 3. Because that's the exponent that I have to put on 2 to get 8. Okay? Again, here in number 2, what exponent do I have to put on to 11 to get that? Okay? So if I put this equal to a box, so then that would be 11 to the box equals 121. 11 times 11 is 121. So this would be equal to 2. Or if I evaluated it, it would be 2. Okay? A couple of special ones here now. Okay? What exponent do I have to put onto 15 to get 1? Well, anything to the 0 power is 1. Okay? So that one is 0. There, I can have an exponent of 0. I can't have a base of 0. So if it jumped around a little bit, it's just me. Okay? So if I set it equal to my box, okay? So then I've got 1/2 to the box equals 8. 1/2 is 2 to the negative 1 power. Exponent rules coming back to haunt us. And 8 is 2 to the 3rd power. We learned that back in example number 1. So if I were to exponent to an exponent, I multiply them. So then, really, since I've got equal bases here, I got to have equal exponents there. So my negative box has to equal 3. So the box then has to equal negative 3. So this is really negative 3. Okay? Now, what happens when it's not a power? If I would do the box method here, I would say, okay, so then this would be equal to a box, and then 3 to the box is equal to 8. Well, I can't rewrite 8 as a power of 3, so I'm stuck. This is where our calculator is going to come into play. And so what we're going to have to use is something called the change of base formula. Now this is something that will allow us to evaluate any log. So if we have log base C of A, what we're going to do to find what the approximation of this is, we take the log of the argument and we divide it by the log of the base. Or we take the natural log of the argument and we divide it by the natural log of the base. Now, every calculator is different, but almost all calculators only have log base 10, which that's called, this one on your calculator is just log. Okay, so that's the key that you're looking for, is log base 10, or log base E is natural log. Okay? So log base 10 is sometimes referred to as the common log. Okay? So we do that. Okay? So if I think about it, log base 3 of 34, well, 3 cubed is 27. 3 to the 4th is 81, because remember, logs find exponents. So this is going to be what exponent do I have to find. So it's going to be somewhere between 3 and 4. Now, when I go to my calculator to do this, okay, so I'm going to use this calculator. So I would find my log key. Now, sometimes the log is an actual key on your calculator. Sometimes it's the second or the control or the shift of one. So in this calculator, it's there. Okay? Now, I want to say log of 34, and then I want to divide that. Now, on your calculator, if your calculator opens up a set of parentheses, make sure you close that parentheses before you hit divide. Okay? Or if it doesn't, make sure you put the whole thing in a set of parentheses, and then you're going to put log in again, and it's going to be divided by log of 3, because that's what we wanted our problem to be. Okay? Log base 3 of 34 would become log base 30, or log of 34 divided by log of 3. Okay? And then when I hit equals on that one, I get 3.2093. 3.2. I forgot 3.209. We'll call it 21. We'll usually round to 3 decimal places. And that, to me, makes sense because 34 is in between 27 and 81. It's closer to 27, so I should be closer to 3 than instead of 4. Okay? On my exponents. Okay? Okay? Log base 34. This time what I'm going to do is I'm going to use the natural log. Okay? Actually, let me show you that one here. Natural log of 34 divided by the natural log of 3 is going to give me the exact same thing. So again, it doesn't matter which method we choose. Okay? If we flip that around, the natural log of 3 divided by the natural log of 34 is going to be 0.132. Oh, 312. Oh man, one of those days, I tell you. Because again, if you think about it, 34 to the 0 power is 1. 34 to the first power is 34. 3 is in between there, closer to 0 than it is to 1. So that's why we're going to go with 0.312. Yep. We'll utilize this again tomorrow when we get into solving. And so you can now do numbers 5, 6, 7, and 8 on your worksheet 17. Thanks for playing along. Have yourselves a great, grand, and wonderful day.